Good morning and welcome, everybody. My name is Gary Grote. I'm the Executive Director for the Greater Aurora Chamber of Commerce, and we'd like to thank you for being here for our second session of Real World Careers Meet the Professionals for this school year. The purpose of doing this is to connect our students and teachers directly with individuals in various careers and industries to provide a background and a pathway to a possible career in that particular field. So we'll proceed in just a second. If everyone can stay muted except for our presenters right now. And we are taping this to archive on our website, www.eanycc, for future use by students and teachers and in the classroom. So our guests today and our presenters are Pete Sergi. He's a Senior Employment Engagement Specialist for Moog. And we have, I think, Dan, correct me if I'm wrong, I'll just use the title engineer.
Yeah.
Okay, is that correct? And Dan Giza, who is with Moog. And we're going to talk about, give Pete and Dan to talk a little bit about Moog, to talk about their respective careers within the Moog company, how they came about to where they are, and then talk about the opportunities there. But then maybe Dan too, just maybe what we can get into is some of the day-to-day things that you might do, just to give our students a sense of what happens with you guys on a daily basis. But Pete, I'd like to welcome you first, and maybe you can give a little background on yourself and on Moog, the company, and we'll start that way.
Sure. Can I share my screen, do a presentation that way? Is that all right?
Sure. Yep. Yep.
All right. It says you disabled the participant screen sharing.
I disabled that?
Yeah, it says the host disabled it.
Okay. Advanced one participant multiple. That okay?
Oh yeah, there we go. All right. So let me share my screen here and get my presentation going here. All right. Hopefully you can see a big white screen there, and then with my name there. Is that all right? Good.
Yep. That sounds good. Looks good. Yep.
All right, perfect. So just I'm going to breeze through this really quick. Pete Sergi, I'm a Senior Employee Engagement Specialist at Moog. Happily married, got 3 kids. By the way, those 3 kids, 2 of them are in college now, so pray for me. It's it's a long financial burden there. I went to West Virginia University. I got my bachelor's in English from there. So I'm a big Mountaineer fan. I've actually had 2 distinct careers, which I'll talk about. I've worked with Disney for 8 years, been with Moog for over 20 years, and then a number of years ago, thanks to Moog, I was able to go back and get my MBA, Master's in Business Administration from St. Bonaventure. So a little bit about my career. So again, distinct careers. I went from hospitality, which is Disney. So I started actually as a lifeguard on their college program, which is a really cool thing. I had no idea what I wanted to do, where I wanted to go in the world. And I went down there making, I want to say it was like $5.50 an hour, $5.50 an hour, which is about minimum wage. Lifeguarding, had a great time. My friend Pluto there. I worked at Typhoon Lagoon. It was really a lot of fun. I actually was a manager at Blizzard Beach for a little while. I enjoyed that. I was a manager at Disney sporting events. So I helped manage the Indy 200 at Disney. Believe it or not, there's a racetrack there, the Clay Court Championships, the tennis event, and the Disney Marathon. I also had a really cool career, a role as a Walt Disney World ambassador, which is really cool. It's I got to represent Disney to the world. So I did a lot of media interviews, press events, openings, things like that. It was a lot of fun. Got to do some really cool things. So that was basically my first career in hospitality. But what was interesting, you saw the picture of my wife. I met her down at Walt Disney World, fell in love with her, would have followed her anywhere, Siberia included. Well, it turns out Buffalo is pretty close to that. So she's from Western New York. I followed her to Western New York and had the opportunity to work for a really cool company called Moog. So I started out as a staffing specialist. So my last job with Disney, I was a recruiter. I recruited students to work on their college program, and I actually had a region of upstate New York as my region. And I really enjoyed that job, but I was spending a lot of time on the road, working very long hours. And my wife was pregnant with our first child, and we wanted to have a little bit more balance. And an opportunity came up to work at Moog, and I took it. And it's been a great career ever since. So my second career is now still in HR, but in a different type of setting. So I started out as a staffing specialist, which was basically, I did a lot of recruiting. I then went into the aircraft group as an employee development manager. The idea behind that role was I did a lot of human resources generalist type work. I supported our assembly and test in the aircraft group, which was over 200 people. And I did soup to nuts HR stuff, hiring, selection, training, development, coaching, counseling, employee relations, you name it. I worked with all of that sort of stuff. I actually had a small role as a manager of change and communications for a very big project that's still ongoing at Moog to transform our ERP system. Changed from that back to the aircraft group as an HR manager, but this time, instead of just supporting the assembly and test operations, I was supporting the entire commercial OEM, which stands for original equipment manufacturer, and our aftermarket. I did that for a number of years. I then became the employee. I went into what's officially called employee relations, now employee engagement. I started as a specialist. I became the manager of the function. I went back to a specialist role so that I could do more learning and development. I'm very passionate about learning and development. I do lots of training at Moog. I develop training, which I really enjoy doing. But I'm also really, I really enjoy doing the employee engagement, which is a lot of employee relations stuff, doing a lot of coaching and problem solving. So I get to the best of both worlds in the new role that I've had for the past almost 4 years now. So that's what I do, and it's been over 20 years. I started in 2001, and so I'll be celebrating 21 years at Moog this year. So what I want to tell you about, and I'm really going quick because I want to get, make sure we get to Dan, because I think Dan's got the more fruitful things to talk about here as an engineer. I think it'll be really great. But so Moog is a large company. We have over 12,000 people worldwide. About almost 7,000 of those folks are right here in the United States, and over 3,000 of those are right here in East Aurora, our largest site of any site right here in East Aurora. It represents the aircraft group, our space and defense group, which is where Dan and I work, and our industrial group, and also a pretty significant contingent that's called our corporate group, which is the support functions like finance, IT, HR, and those sort of things. So there's a number of career opportunities if you're looking to a place like Moog. And the most obvious is engineering, because that's a lot of what we do. We design products that in the realm of precision control that nobody else can do. Nobody can do what we do as well as we do it. Oftentimes our customers may actually go out and find someone that does what we do, and they might save a buck, but in the end, they oftentimes come back to us because they're like, no, nobody can do it like you do it, especially if it means, safety sensitive equipment that's going to go on airplanes, rockets, missiles, defense equipment, medical equipment. That's what we do. And we have engineers that do design work, product work, project work. So there's a number of different things that you can do as an engineer. We also have areas, not so if you don't want to be an engineer, but you really like getting your hands dirty, working on product, all the time. We have lots of opportunity in our manufacturing operations, anything from machining to assembly and test. People have built long, fruitful careers here at Moog. In fact, we have employees that have been Moog for over 50 years, doing almost the same thing, but they love it, they enjoy it. There's always a challenge, and so we have opportunities like that as well. You can also do things like supply chain. So if you think about getting something from raw material to out the door, there's so many pieces involved in doing that, and that represents the entire supply chain. So people that work in those fields, as well as HR, finance, IT, programs, contracts. There's really, it's a pretty broad spectrum of careers that you can get at a company like Moog. And so that's really, really good to know. So what are we looking for? So if you think about, what a company would look for in people that are going to be coming there to apply there, whether you're applying for a full-time job or maybe an internship or a co-op, I call these the KSAs, the skills, knowledge, and abilities. Obviously, we look for very critical technical skills. If you're going to be an engineer, if you're going to be an assembler, tester, machinist, you have to have some foundation, and not just a foundation in that knowledge, but also a passion and a desire to really want to do that on a regular basis and solve problems and work through really critical technical challenges. And on the flip side of that, we look for really important behavioral characteristics. Moog has a unique culture that actually is a dichotomy of two really interesting and very critical aspects. One is this element of trust that is expected, with people, management and employees, but also this element of really important individual responsibility. So people taking it upon themselves with minimal direction to do what's right and to make sure that they're meeting the objectives that they're expected to meet, all the while building and enhancing and nurturing relationships. So those are really important, those behavioral things. Having people with good mechanical aptitude that really like being hands-on and problem solving, that's really important. If you said, I don't want to touch that, I don't want to get my hands dirty, and I don't really like problem solving, I don't know if Moog would really be a good place. There are probably companies that might benefit, but if you really like getting your hands dirty, you really like being hands-on, you really like doing that problem solving, and you get, kind of that you get energized from that, I think you're going to really enjoy a company like Moog. We do lots of project management. We have massive projects, things that go on. I mean, we're putting stuff that goes on Mars, right? Right now we have stuff that's on the planet of Mars, to give you an idea of the scope and magnitude of the projects that we work on. So you have to have really good project management, people that are able to work across functions, across groups, across sites, across time zones, to be able to collaborate, come together, solve problems, build relationships, and to be able to do that. So those are the things we look at in terms of skills in it. Education, at a minimum, you would need to have some sort of a high school diploma or equivalent to be able to come into Moog. And we do hire people, with that. But if you're looking to say, hey, I'd really like a career at a place like Moog, it's not a bad idea to go off and think about, what kind of field do I want to go into? If it's an engineering field or if it's a technical field. Many of the folks at Moog, have a associate's degree in some sort of technical field, or a BS in some sort of technical or related field. So we have lots of people, with a Bachelor of Science in engineering, or even finance, or something like that, all the way to people with, like me, like a Bachelor of Arts in English. You may say, how does that actually technically apply to Moog? I would not have been recruited in Moog right out of the street with a BA in English, but my career at Disney really helped me do that. Plus, it's helped me, in terms of the things that I've had to do with communications and whatnot over the years. And then if you have the desire and the passion, you really want to further your education, and you're really about learning, you can go off and get maybe a master's in science or an MBA or something like that. And we've got people, with high school diplomas, associate's degrees, bachelor's degrees, master's degrees. We even have people, believe it or not, with PhDs. It's not very common, but it does certainly happen. So so that's really what we're looking for. And ultimately, in the end, I think, Bill Moog sums it up, really well. He's our founder. He founded the company in 1951. He passed away in 97. But not before he helped really build a solid foundation on, trust, mutual trust, needless formality, saying we're going to get rid of that needless formality. And the idea is, that individual responsibility, that personal accountability each person takes, is what that trust is built upon. And so if you're looking for that type of environment, Moog is the pioneer of that. Bill Moog was doing this before others even thought that was a good idea. So I guess what I'll do is, I don't know, Gary, should I pause for questions? Should I go right into Dan's presentation?
Well, why don't we, I haven't seen anything in the chat room yet, but I did have a comment though, Pete. I mean, over the years, I've been to Moog a number of times. I've been to presentations that you've done, and some of your other Moog employees, some of your engineers, and just the passion. And you can tell, what you have when you talk about Moog, and just the passion and energy that everybody has there. And like you said, the culture that's within the company is really, it's great to see, and it's exciting. And even as a person on the outside, it really gets me, wow, this would be a great place to work. So I just wanted to mention that. So I don't know if there are any questions that come up, just go in the chat room. From Ron Pascoletti over at Moog, are there internship opportunities at Moog?
Yes, and actually Dan can also allude to this when he goes up, but yes, we do hire interns. Many of them are in our engineering field. That's probably where if you were to say like Moog, actually in East Aurora, I want to say up and down our campus, we had close to 100 interns, I want to say last year. And most of them are in engineering. We have some in finance, some maybe like a handful in HR, some in supply chain, some in IT. So, but most of them are in engineering. So yes, we do hire interns. It's a big program for us.
Okay, and I think you answered with those comments the second question that Ron had. How are they structured? And I think you kind of addressed that a little bit. I don't know if you have any other comments on that. I mean, can the schools reach out to you to get that information, or they go to your website, the Moog website, or?
Yeah, both. They could do either. There is information out there on the website. We typically partner with certain schools, so we don't go to every school. But there are certain schools we'll typically work with in terms of especially like engineering. So for example, UB is right in our backyard. We have many folks from UB. In fact, Dan is a UB grad, so that's a huge partnership we've had. But we'll go off to places like RIT every now and then, like Rensselaer Polytechnic. We've recruited interns from Cornell University to Ohio State to Northwestern to Virginia Tech. I mean, so it's been, it really just depends. And then that's really engineering, but we've hired interns from, in finance from like Canisius College or, some of those other local schools. So yeah, it just really depends. So yeah, there should be information out on the website, but if you're having a hard time finding it or whatnot, just go ahead and give me a shout.
I guess maybe the question may have been to opportunities for high school students, or is it just mainly college students right now?
That's a good question. It's typically mostly for college students. We used to do, like small like shadowing programs for high school students, like and those are usually very one-off, ad hoc sort of things. But that was prior to COVID. Since COVID, we haven't really done a lot of those things yet, and maybe we'll get back into that once we kind of fully leave the pandemic phase and get into the endemic phase and start getting back to those things that we used to do prior to COVID, where we would maybe offer a student to do some sort of a shadowing sort of thing. But oftentimes our interns, what they're doing is they're taking some sort of knowledge or skill that they're learning in a classroom, especially at a collegiate level, and they're applying it to Moog, and we're giving them work that's commensurate with wherever they are in that education. We don't always easily translate that at the high school level, but that's not to say we would never do it. It's just not something we do in great volume.
Right. Well, great. I think that probably gives Ron a better answer in his class, a little better answer. So I guess I'll let you turn it over to Dan then.
Yeah, I'm gonna stop sharing. Dan, you can go ahead and share your screen. This is Dan Giza.
Sounds good, thank you. And I do have a couple charts, like Pete had mentioned, on interns and co-ops. I work with quite a few co-ops in my kind of role at Moog. Try to share this. Hopefully everyone can see the PowerPoint.
Yep.
Okay. So my name is Dan Giza. I'm somewhat more recently became an engineering section head. I've been with Moog for about 12 years. Just a quick agenda. I'm going to do a little bit about me, just like Pete did. Do a quick overview of Moog. Some of what Pete had shared was a great lead in. Some of the stuff you'll see is maybe a little bit repeated because we're both kind of have done talks like this before. And then I have a few other slides, but I really wanted to, if we're getting close on time, or if there's any other topics that you guys absolutely want to discuss, I am totally happy to stop at any point and start doing questions or just take it in a different direction. So this is up for you guys and what you guys want to get out of this. So like I said, I'm now a section head in our a relatively small group at Moog. We focus specifically on failure investigation and prevention. Pete kind of alluded to the fact that we make some pretty high-end components for our customers, and it's very critical that they perform when they need to perform. And so for the last decade or so, this group was kind of started when I was pretty new at Moog. We've had this group that we focus specifically on trying to solve those critical problems when they do happen. As Pete mentioned, I did go to UB. I graduated with a Bachelor of Science in Mechanical Engineering in 2008. I continued straight on for a Master's of Science and actually finished that while I had started working at Moog. I started at Moog in 2010. While I was at UB, I competed on the cross country and track and field team, Division I for 5 years. And then I actually went back to UB while I was working at Moog. And as Pete had mentioned, similar to his MBA experience, you know, I did get tuition reimbursement of that through Moog. Before I started at Moog, I worked for the Air Force Research Lab. I spent a summer in Maui, Hawaii, which was, you know, pretty tough. And then I've been at Moog since 2010. I started in product engineering. And then, like I mentioned, you know, after a few years, I moved into a role where I was specializing in failure investigation, did a brief period of time as a systems engineer, and then kind of came back to the failure investigation world as the section head, and now lead that group with another engineer of mine. Again, I went back to school. I went to University of Wisconsin for a few additional additional classes that were pretty specific and you know, in terms of the content relative to what we do at Moog. And I'm married with 4 kids. Hobbies are now mostly my 4 kids, but I also like to run occasionally still. There's a lot of education on this slide. I like to mention, you know, Pete was kind of touching on the different roles at Moog, and I do go into that a little bit as well. You know, this amount of education, I don't want this to scare anybody away. It's just what worked for me. I really enjoyed it. But, you know, as Pete had mentioned, there's all different levels. There's lots of different opportunities for machinists and technicians. There are some engineers, as Pete mentioned, that, you know, have up to their PhD. And so this is what worked for me. This is what, you know, I chose as my path, but this is certainly not the only path to working at Moog or any company like Moog. So this is me and my wife and our 4 kids there. The one of them, she's just 6 months old the other day. And then the other 2 are, you know, 9, 8, and 3. I picked some of these pictures to kind of show, at least for me, where my engineering passion kind of comes out in my personal life. I think I heard that there was a CAD class on the line. I actually designed and built this playset here myself, and I modeled it all in CAD before I did it. And so, again, you know, not that you have to have an engineering degree, of course, to do something like this, but it's just what, you know, kind of what helps me do things that I really enjoy in my personal life as well. Same thing with my, you know, my son's Halloween costume there. And just a few other ones. You know, I get into a little bit of everything. I've been doing work on this, you know, rusty old pickup truck for the last 8 or 9 years, and then, you know, built my kids some pretty cool looking bunk beds somewhat recently too. I wanted to include a couple pictures of what I've worked on as a Moog engineer, a few highlights, I guess, if you will. Again, a nice segue from Pete. I was a product engineer on some hardware that went onto this spacecraft, which is currently orbiting Mars. So I got to physically hold in my hand a piece of hardware that is now orbiting the planet Mars. And our direct customer was Lockheed Martin, but you can see all the different, you know, partnered, you know, their customers, NASA, of course, and some other research laboratories in Colorado. We do lots of technical control systems for missile and defense applications. And then this here is a second stage rocket engine. This goes on the ULA launch vehicles, the Atlas V. And I circled in green, if you can see, a Moog actuator. So when Pete had mentioned precision control, you know, that is very much what we do. And this actuator controls the thrust direction for that rocket. And there's actually 2 of them. This is the only one that's easily visible here. Hopefully the next slide plays. This is actually a video of our actuator during a launch. And so right now you don't see anything because the first stage of the rocket hasn't separated yet. But before I hit play, this is one of our actuators right here in the video, if you can see my cursor at the bottom. And it's not that long, but what you're going to see is the first stage of the rocket's going to separate. This is already quite high up in the atmosphere, effectively in space. And what's moving that rocket left to right or up and down is our actuation system. We make both actuators. There's 2 per system, as well as all of the electronics that control this. And so as this vehicle gets whatever its payload is, typically some kind of satellite or potentially supplies for the space station up to orbit, our actuators and our components are what are helping it to do that.
But then I just got to say, cool.
Yeah.
That is
Yeah,
something.
and this is a video that's basically the same videos that they share on YouTube. So if you went onto YouTube and searched, most launch vehicle companies like ULA or Lockheed Martin or Orbital ATK, there's lots of launch videos like this, and most of those launches will have some kind of Moog hardware on it, like Pete was kind of mentioning. So this is a launch where once the initial engine is fired, which it is firing now, you just can't see it because contrary to what usually is shown in the movies, there is no oxygen space, so you never see actual flames or burning going on. But this is what our actuators should do, just kind of hold position and not do a whole lot of movement. That's a kind of a nominal ideal flight. So this is a little redundant, but kind of just to echo what Pete was saying, we do have, this is just SEG. So Pete was saying there's a couple thousand employees across our East Aurora campus. We're very engineering heavy because East Aurora is our headquarters, and this is where we do a lot of our design and manufacturing. So we are, in SDG, at least Space and Defense Group, we are about 1/3 roughly engineering, and that is mechanical, electrical, some computer and software system engineering, but we're also pretty operations heavy, manufacturing heavy. So we have quite a few technicians, machinists, operators that actually physically make and assemble and test those components. All of the hardware that I was just showing on the previous screen, that actuation system and everything is manufactured, assembled, and tested in East Aurora, and then delivered to our customers across the country and across the world. And then we also have a big part of our business that is program management, sales and marketing, accounting. Of course, people like Pete and others in our corporate groups that are focused on learning and development and in HR side of things as well. And this maybe will shed a little bit more light on some of the questions on the co-op program. Like I said before, I've been a pretty big part of the co-op program for the last several years now. As Pete mentioned, we do have quite a large co-op and internship program, especially over the summer. We can have upwards of 100 co-ops on the East Aurora campus at a time across all of our different buildings. So we do hire students across all of our departments and functions. I agree with Pete. It's probably a higher percentage of them that are engineering based. A lot of schools even require, like RIT is a school that requires a co-op or an internship to get your degree. Most commonly, we have students start after their sophomore year. Occasionally, we do have one that starts like mid-sophomore year, maybe the spring of what would normally be their second semester of sophomore year. So early on, and someone I think the question was asked about the structure of the program. So early on, the ratio of mentoring to work output is very high. So there's a whole lot of mentoring going on, and there's really not a ton of expectation that they're going to produce a lot of usable work because there's just a very, very steep learning curve when you're coming out of not a lot of college education and stepping into this precision manufacturing environment. But typically we structure those tasks to be a small piece of whatever the overall task is to support production or design, or in my case, typically some kind of failure investigation. But eventually, and what we really, really shoot for is to slowly let those students take on more responsibility and autonomy. And so usually what I prefer to do in my group is have a student in for the summer and the fall, or the spring and the summer. And what that does is it really provides a lot of opportunity for that learning early on. But then after 2 or 3 months, when you've really learned a lot, it's unfortunate to have the time end there at that time. So we really like when we can extend it a little bit further, and then use the next 2 or 3 months to have them take on a larger role, take on more responsibility and autonomy during the second half of the experience, And they'll go from, knowing nothing about Moog and the products that we make and what we do, to at the end, I've actually had students leading conversations with Lockheed Martin or with Boeing, preparing the slides themselves, actually presenting them and fielding questions. Of course, we still work with them and mentor them and all of that, but they really do get a chance to take on a lot of responsibility if they kind of work themselves toward that. Again, Pete kind of touched on this. A lot of it was great segue. It's just nice to hear it from two people's point of view. And I think even Gary had mentioned, he's kind of seen our culture and our philosophy and heard a lot about it. It really is true. I mean, I had heard a lot about Moog before I started at Moog. I grew up in the Buffalo area, so I was, from this area. So I'd heard of Moog before. I'd always heard of people saying it was a great place to work. And it really is. This is really my only career. I did have that one internship experience with the Air Force, but I've never found a reason to leave. It really is the behavior and the culture and the people that you get to work with. As exciting as the technical content is, which that's certainly important to me, it is very much about the people that I get to work with every day. And honestly, the pictures I shared of the stuff that I've done in my personal life, there are so many people at Moog that do so many different things as far as hobbies that it's just an amazing place to just learn from each other, whether it's related to what you're doing at Moog for work or what you're doing in your personal life.
For next year, period.
Is there a question?
No, I think we're getting some feedback maybe from the school, maybe on I think we're all set. I think we're all set.
Oh, is this the announcement or something?
Yeah.
So I'll just breeze through a couple of these. These are, we actually have a booklet, or I guess different variations of this that we share with our employees when they're hired, and then periodically, we kind of, go back and read them ourselves. These are just our Moog values, and really, there's Pete's got the booklet right there. We often come back to these. Sometimes we have to remind ourselves of these, but for the most part, everybody really kind of remembers that this is the way that we behave, this is the way that we treat each other, and it is really a great environment to work in. So again, I have a few more slides. I'm happy to keep going through them. Please, I don't know exactly how much time you had kind of planned or prepared, but if we get to a point where you'd like to have 15, 20 minutes or whatever it is for questions, just, please feel free to stop me.
Well, Dan, we still have a few minutes, so you can go through some of the slides, but yeah, I'd like to offer an opportunity to anybody if they have questions to submit those, and I hope there's some out there. But why don't you go forward with a couple of the slides and we'll see what happens. We do have time, so.
Okay. So I actually presented these slides to a college class a few months ago, and so the intent of what that class had kind of asked for was, how do you get the career that you want, whether it be Moog or somewhere else. So some of these are a little bit general and do I think kind of speak to my personal experience a little bit as well. Prepare. I'm sure your teachers and your parents and all these people have said this your whole life. But it really is true. I meet a lot of students, and the ones that always stand out and really distinguish themselves from others are the ones that are really showing a passion for whatever it is, if it happens to be engineering, if it's business, or whatever. Academically, that is one way to exert yourself. But oftentimes, that isn't even what necessarily distinguishes somebody from someone else to me. It isn't always just about the GPA or the fact that, they just got straight A's and everything. The ones that have made, and taken the initiative and tried to find those opportunities for shadow experience or volunteering, getting involved in hobbies and clubs that aren't required outside of classes, or doing a co-op or an internship that isn't required, outside of your classes. So academic is important, especially for engineering. But there's a lot of other ways to get really good relevant experience and distinguish yourself from others. So some of my personal big takeaways, these are my opinions of what it takes to get the career that you want and really enjoy it. really, really pick a career that you think you'll enjoy. That's not that you have to enjoy every single aspect of it every single day. There's certainly days at Moog that have been more enjoyable than others. There's certainly more that have been enjoyable than not, in my experience at least. But I would have a very hard time going to work every single day if it weren't for both the people at Moog, but also, that I really do truly enjoy the technical challenge and problem solving, some of the stuff that Pete was kind of covering before as well. I am very, very fortunate to have had some amazing mentors in my life, both in school and at Moog, and still have them at Moog. But you'd really have to recognize those opportunities to recognize that this person is willing to invest in you and to help you be better. And so be humble enough to learn from them. It's not just what they do for you, but it's how they help you become better quickly. Similar to the kind of mentor comment there, recognize that there's every relationship's a two-way street. It's just not that you can expect to just get taught a class from a teacher or get advice from a mentor and then just automatically get better. You have to put in a lot of work too, and really take that feedback and criticism to help get yourself better. And then the last one, which is, I think what you've kind of been hearing me say, what I get to do at Moog, every day, is do amazing things with people that you like to be with, and whether that's in a club or a sport or anything that you're doing, just really, be trying to do the best that you can and get as much as you can out of it. So my last few slides were very specific, and again, this was kind of put together for a college class, and I'll happy to go through it. It was pretty specific to our engineering design process. So I guess it's up to you if you feel like this is a better time to stop and ask questions, or if you'd like me to go through these as well.
Why don't we ask for questions first? See if there's
Sure.
anything. I don't know if anybody has anything. You can throw it up on the chat room. Okay, nothing's coming up yet. I do have one for the end, but why don't you said you have 2 more slides, Dan?
There's a few more. I think there's a slide for each one of these phases. So this was more specific to engineering and, how do we, from cradle to grave, if you will, when a customer comes to us for a new design or for some kind of component, what does that process look like at Moog?
Well, let's maybe we can get Pete back on too, and maybe both of you can contribute. I guess have a couple comments and maybe a question in terms of the okay, we've got a question. I'm not sure who it's from. Are there many on-site projects? I'm not sure what that means. I don't know, whoever submitted that, if they could maybe follow up with a little more detail on there. But in terms of the future of Moog and employment and opportunities, does that in the future, does that those employment opportunities look to, stay the same or grow? Or is that?
Do you want me to answer that, Dan? You want to go ahead?
Yeah, you can try. Sure.
Okay. See, Gary, you're asking if there's if Moog's growing or shrinking.
Well, no, I'm just asking. Yeah, I don't mean to put it in that format. I mean, just the opportunities will continue to increase at Moog. I'm assuming that there, because we're talking to high school students, that maybe in 2, 3, 4 years there'll still be those kind of opportunities out there.
So I in general terms, I'll say yes. So I joined Moog in 2001. We were a $700 million a year company worldwide. We're going to probably cross 3 billion potentially this year or next year. And in the next couple of years, the Space and Defense Group, which represents probably just under a third of the business right now, will cross the $1 billion mark as well as just a group, So there's a significant amount of growth that we're looking to do. We're expanding into different markets, and also doing things with legacy markets as well. So we're doing quite a bit to diversify ourselves across these things and to really emphasize on innovation such as electrification. That's a big thing that we're going to be doing over the next several years. We've actually set up a whole function to really look at electrification. So what electrification is, and we're actually starting that is in sort of production equipment. So for example, a small bulldozer or what do they call that? Like a bobcat. We're actually starting to electrify those so that you can, so instead of actually having a person do something like that, you can have it be totally autonomous. Things like helicopters. Cool studies that we've been doing is electrification of, so for example, if you've seen those big solar fields with like solar panels, and all that, well, those need to be checked on a regular basis. And the only way to really do that is to have someone walk out in those fields and do that. Well, we're figuring out ways to electrify vehicles and machines to go out and do that. Instead of employing someone to go out there and do that, they can do that. And that goes to something from a solar panel field to farming almonds. So if you think about almonds that go in, you buy a package of almonds or almond milk, it's almond industry is huge. And we're looking at vehicles that can go off and help us farm for those sort of things. And it's really fascinating, some of the things that we're doing. So to answer your question in a very long-winded way that I just did, we're looking to grow. Yes.
That's great. That's some great opportunities. There are a couple of questions that came in. Let me go back down here. The one with the structure, let me see. Are there any on-site projects? The question was on-site, actually on Moog property for that particular client. And I'm guessing that you talked about some of the like the actuators and stuff that you build, and you ship them to a client. Are there things like that you actually major project? I'm trying to interpret the question a little bit to see if there were those kind of projects that happen right on site here.
Yeah, so absolutely. So that the projects or the ones that I chose to highlight on my slide, those were all components manufactured, assembled, tested in East Aurora. And high volume for us typically is maybe like a dozen. We really don't do almost anything that's high volume. We do tons of variety, low volume, high precision components. And so there's hundreds or thousands of different projects and programs that we're building, 10 of these and 15 of those for a variety of different customers. But a lot of them are happening on the East Aurora campus. I know I have a little bit more direct knowledge of Space and Defense Group. And so sometimes we have programs that will initially design, develop in East Aurora, but then we have other facilities like our Salt Lake City facility in Utah, where we do our higher volume production. And we have facilities in California and Golden, Colorado that also do some production work. But yeah, there's hundreds or thousands of programs that are being built and tested and assembled in East Aurora.
And if I could, Gary, too, I'll add to Dan's a little bit to the on-site piece. So we do a lot of, as Dan said, we do a lot of work on site here in East Aurora because we are a design as well as manufacturing house here. But it's not uncommon for a person who maybe is an engineer or even a technician to travel to a customer site. So a lot of what we do is not just designing, developing, and then shipping and saying, here, take it. A lot of what we're being asked to do by our customers as we become more of a prime supplier is what's called integration. So we'll be doing a lot of integration. So that may require us to go there and say, okay, here's how we integrate it. So we're kind of putting people in those forward locations to be able to help us to do that. But much of what we do is on site right here, and oftentimes the customer will visit us on a regular basis. They'll work with us to help us get from to what Dan's looking at there, from that initial design all the way through to production.
Okay, thank you. We got two other questions. I'm not sure which one to lead. I'll lead with. We talked. There was one of the questions was, what are they? There are so many positive things that happened at Moog, really the energy and everything else, the great culture. Are there any things that aren't as positive that are there negative aspects of
Yeah.
your career? I mean, it's kind of an odd question, but
Yeah. No, that's, I mean, I can take a shot at it. So it's mostly positive, I would say, for at least for myself. But I will say, so one of our values, I think, we've had it up there, is, work-life balance. And I'd say for the most part, Moog, and compared to a lot of other places that I either have friends, family, or colleagues that have moved on to somewhere else, it is, very much respected. And for the most part, it is, really managed well. But there are definitely times where, there's times where things have to get done, and there is things about overtime or things that happen last minute. Those things definitely do happen, especially in the engineering side or the assembly and manufacturing side. If there's things that are critical to our customer's deadline, it kind of works both ways. We get a lot of flexibility in that respect. I think comes from our management most of the time, and then for that reason, I think a lot of people are kind of willing to make a little bit of a sacrifice at sometimes, and sometimes that is a little bit hard.
Okay, great, thank you. And then I guess we can wrap up with this last question, and then we'll have just some general comments and stuff. But you were kind of addressing this earlier, Dan, around Pascaletti over at Ormsby in the class, about the cradle to grave process that you started to talk about.
Yeah. So if that's okay, I mean, I can go through these next couple slides.
Yep.
Just as a time check, do we have until 10, just so I know, or?
Yeah, if we can maybe finish up about, what time is it now? Maybe finish up in about 4 or 5 minutes, and then we'll just wrap up, okay?
Yeah. So this is just kind of a very high level of what our engineering design process looks like. So sometimes a customer comes to us and asks for something we've never made before. Sometimes they come to us and ask us to just make more of something. And so if it's just make more of something, we're jumping right into production. If it's something brand new, we're starting all the way up at the top at proposal. So proposal looks something like a customer provides a specification detailing what they want something to do. Typically, they're coming to us in the first place because it's very specific. They know the type of things that we make and what kind of products we offer. Sometimes they already have an idea of what they think the solution is going to be, but they give us some document, it can be as little as 10 pages long, sometimes hundreds of pages long, saying, here's all the things that this thing must do for our higher level system to work, if that's a rocket or a spacecraft or whatever it happens to be. And then we respond with what we think would be an appropriate technical solution. We put a lot of detail into that kind of document to say, this is exactly how our product is going to meet all of these things that you need it to do. That'll include the cost, the schedule. Sometimes if it's something brand new, we'll identify our level of confidence. So if it's something we've never done before, there's likely to be some risk associated with a design, and we'll typically have recommendations for how would we go about reducing that risk, or here's the things that we're going to check and try to make sure that we're retiring some of that risk along the way. If it really is that kind of a new design where we do identify some of those risks, we'll do that initial design and sometimes some risk mitigation activities. Of course, we always look at do we have any heritage designs that are close, and there's oftentimes a lot of discussion and deliberate thinking about how do we get to that best technical solution. Sometimes you're making a trade matrix to evaluate different design concepts that are sometimes at odds with each other. We call that the goalposts, and sometimes the goalposts get really narrow for our designs, meaning it's very, very hard to meet this requirement and that requirement and still meet some of our other goals like cost and schedule. We have tons of different ways to do analysis, throwing out some words that some may or may not be familiar with, dynamic system modeling and FEA analysis. Those are kind of higher level engineering type classes that you would end up taking in college if you ended up going for engineering. But the best thing is eventually we get to some level of testing where we take a physical piece of hardware and try to do as much testing as we can to get real data to help retire some of those risks. And then we iterate and refine. So as we have a test that doesn't quite go as well as we'd like, or doesn't quite meet a requirement, we try to refine that design such that it does meet the requirements and what our customer needs. Engineering development is when the design is mostly finalized. We've done whatever risk mitigation we think we're going to do. We think this design has a pretty reasonable chance of passing and meeting our customer requirements. We've retired most of what we think is high risk. And we try to do some amount of development testing. Sometimes we do this with a subset of the parts or omit certain features to increase schedule and decrease cost, or I guess decrease both, increase the speed at which we can get things done. But the intent is to perform and build and test for weakness areas that before you eventually qualify your product. Sometimes our cost and schedule doesn't allow for full development. And then unfortunately, sometimes that does lead to a situation where we do fail later on. But that decision is usually made with our customer. We tell them, we don't necessarily have the time or the budget to do this development testing and still meet your schedule, but we're all going to collectively agree that the risk is worth proceeding. Qualification. So this is when the design is truly finalized. You're locking it in. This is a big milestone of a program. You present a CDR. CDR is potentially, that's maybe one of the toughest or most stressful days as an engineer. You're taking sometimes years worth of work and trying to present that in a day or two to your customer. And the point of that meeting is to, like I said before, describe to them all of the ways that your product is going to do everything that they want it to do. Oftentimes after that, we'll produce a whole bunch of units, whether that be actuators or valves or any of the components that we make, and we'll choose a single unit at random to be a qualification unit. And that one's going to get tested way more than any of the other units. It's going to be, we've shock and vibrate components to make sure they can handle launch environments. We do thermal testing as cold as -300 degrees. So we really, kind of put it through the ringer, if you will, to make sure that even under those extreme environments and conditions, it's going to continue to do everything our customer needs it to do. And the configuration, meaning all the parts and their sizes and features and what material they're made with and everything, is identical to what we're going to eventually deliver to our customers. And then assuming that you've passed qualification, which is very difficult to do sometimes, then you enter production, which is a big part of what our facility does day to day. You are, we're not changing that design. There's very little flexibility for any changes. You can't change big things like materials, or you can't take parts out of or put new parts into the design. And if there is ever a situation that occurs where you do need to change parts, whether that's a customer says they need more performance or different performance, or you have a failure, that can oftentimes drive additional qualification testing. So a little bit of going back to the drawing board, saying this is now what the new design is going to be, and here we have to go and do these extra tests to really make sure that we can kind of go back into production with those changes. So hopefully that wasn't too quick. I was trying to make sure I kind of covered all the slides there. But
yeah, Dan, just quickly, is this process? I mean, when you have a customer come to you, I'm sure it's a competitive kind of process that Moog, you're competing with other similar types of companies. Do you have to go through this process as part of the competitive nature of bidding and things like that? Or is this when you finally come to an agreement that this is what we're going to do and this is the plan that you follow to get to the final product that goes out to your customer?
So production, this slide specifically, production, that's usually after you've kind of already won the bidding process.
Okay.
The bidding process is more happening during the initial proposal phase, potentially during the design risk mitigation phase. So that's when the customer is potentially still trying to decide between Moog and another supplier. And so the proposals, when we're trying to tell them, here's the cost, here's the schedule, here's how our design is going to meet your technical solution. And if they feel that another supplier has a better technical solution or can do it at a lower cost or a faster schedule, we do occasionally lose bids, certainly. But I think Pete has mentioned too, there's times where we lose a bid and then later they come back to us, because there's issues that happen with that supplier. So this is the time during the proposal phase where you're more, kind of into that bidding process, whereas the production is more like a request for quote. They're saying okay, you're qualified. We know this thing is going to do what we needed to do. Now we just need to order 15 or 20 of them or 100 of them.
Right. Now, and just to kind of wrap up, and maybe should have asked this a little earlier, but it kind of ties into what you just explained. That actuator that you talked about that was on that vehicle that was going around Mars, from the beginning of the process that you just described to the end, what kind of time frame are we talking about to get that to a customer?
So that one's been in production for quite a while, but I'd say the typical timeline is, it's on the order of years. So, usually I'd say the proposal process is maybe only a few months, right? Where we're kind of roughing out, here's what we think we can offer you. But the initial design and the development phases, those can last years. Qualification, I would say by the time you're at that point, you're talking 6 months to a year, and then production is just ongoing. But most programs extend over the course of at least 1 to 3 years for those initial phases.
Yeah, I thought that was interesting, and thinking back to what the process that you had in that actuator that you were showing. Just kind of curious. And well, let's wrap up here. There aren't any other questions on the chat room. There were some comments that this is a great presentation. Truly, really, I think it answered everybody's questions and you guys give a good representation for Moog, and congratulations, and thank you both very much. I don't know if you have anything to say to wrap up, or Peter, Dan? No? All right. Well, great. Well, thanks everybody for being part of this. Again, thank you to Pete and Dan for their great presentation, and for those of you who've joined us. And just a reminder that this is recorded. You can go to our website too to see another, copies of the presentation, www.eanycc.com. And our next presentation will be Wednesday, March 2nd at 9 a.m. And we'll get back to you with more information to the schools about that. So again, thanks, Dan and Pete. And thanks everybody for joining us, and have a great day.
You're welcome. Thank you.